In this lesson, we're going to look at transformations to parent functions. So parent functions are your simplest functions in a family. So our most basic one that you first learned like way back in Algebra 1 was your constant function, something like y equals 2. Then we went on to linear functions, y equals x, where your crosses at the origin and has a slope of 1 is your parent function. Quadratic has a vertex at the origin, and 1, 1, 2, 4, 3, 9, etc. are ordered pairs. Here's your parent function for the cubic function. And then in Algebra 2, you started getting into the square root function, absolute value function, and the parent function for your reciprocal function. Notice you've got a vertical asymptote here at 0 and a horizontal asymptote at y equals 0. So the general format for all transformations is what you see on your screen. And that might look complicated, but all it's really stating is we start with some parent function, which I'm just calling y equals f of x. If something is happening to the x value, it's written inside parentheses. So you're either multiplying or adding and subtracting from your x value. We call these b and h. And they're going to change your graph in a certain way. A and k here off in the ends affect your y value, and they will both control the graph in a different manner. So let's look at what they do. So hopefully you've completed your Desmos exploration to see the effects of these different letters. But if we have, let's look at what happens with addition and subtraction. So if it's added onto your y value, that's going to be k. All right, so I'm going to put a k here. And that's going to translate or shift up or down k units. Now, if you're adding or subtracting onto your x value, well, it's h that controls that. And h always kind of works opposite of what you think. Since it's being added onto your x value, it's going to translate left or right h units. But because there is a minus sign in here, you should have seen in the Desmos activity that if you had something like x plus 2, it's actually going to move your graph to the left, meaning if you had y equals x plus 2 quantity squared, this would move a quadratic function left 2 units. So a little counterintuitive, whereas if it's x minus 3 quantity squared, this actually moves it to the right 3 units. Okay, so I'm actually going to drop to the bottom of this chart and talk about what if I have a negative value. So I'm talking about if a is negative, this is what's going to affect my y value or my f of x. Okay, so if my y's suddenly become negative, this causes a reflection, also sometimes called a flip, across your x-axis. You'll hear people also refer to that as a vertical reflection. So b, what if b is negative? Well, that's going to be a reflection as well, but it's going to be a horizontal one, so it's going to reflect across your y-axis. Now, when we talk about multiplying, the value that also affects multiplication of your y's is your a value again. But I've already talked about if it's negative, so we're going to break this into two categories. The magnitude of a is going to affect whether you have a vertical stretch or a vertical shrink. So if the absolute value of a is greater than 1, you have a vertical stretch. Whereas if the absolute value of a is less than 1, you have a vertical shrink. Sometimes that's called a vertical compression, and this is always by a factor of whatever a is, by a factor of a. Now, it's the b value that we're going to talk about for a horizontal stretch. Like imagine taking a piece of paper that has your graph on it and you stretch it out horizontally. This, just like the h value, kind of works counterintuitively. So if you have the absolute value of b is greater than 1, this is horizontal, you probably want to say that it's a stretch, but it's actually a shrink or a compression. And if the absolute value of b is less than 1, so you have a small fraction like a half, you actually have, again, counterintuitive, it's a horizontal stretch by a factor of the reciprocal of b. I just wrote a. Let me fix that to a b. All right. Now, the order in which you complete transformations does matter, and different textbooks are going to tell you different things. Here's one acronym that'll help you get things in the correct order. So we're going to do AHBK, or you can come up with your own mnemonic device. A group of kids once said, "All hail Burger King," AHBK, to get your transformations correct. So we're going to use the graph of a parent function to describe our new graph h of x. So the parent function here would be a cubic function. So for a cubic function, some of the critical points would be if I pick -1, plug it in, I get -1. 0, plug that into x cubed, I get 0. Plug in +1, I get 1. So my parent function for cubic looks like this. It's continuous. It's kind of almost like two halves of a parabola, kind of opening opposite directions. But what I now have is I have a k value that's being subtracted. Right? So what's it doing? It's going to shift my function down 5. So all I need to do is subtract 5 from each of the y values to get my h of x value, which is going to be -6, -5, -4. Therefore, my previous x values and these y values are going to be my transformed function. So -1, -6, 0, -5, and 1, -4. It's going to be like this. So all it's done is it's shifted or translated my function down 5 units. So in the next one, I can see that something is happening to my x value. So the parent function here is going to be a quadratic function. So I would have x, and it would be f of x equals x squared. And if I think about some critical points needed to graph that, if I square -1, I get +1, square 0, I get 0, square 1, I get 1. To graph this, well, you do 2, 4, and -2, 4 to make a smoother curve. Here's my parent function. Now, h here would be 3. Okay, so something is subtracted from x, which actually moves, it's counterintuitive, to the right because the h value is actually +3. So I'm going to actually add 3 to each of my x values from before. So my new x value is going to be 2, 3, and 4, and my y values would remain the same for g of x. And then I'm just going to plot them to 1, 3, 0, 4, 1. And it certainly wouldn't hurt to add the other ones. And I kind of missed. That's not the smoothest curve, but you can see it has shifted 3 to the right. Now, I would encourage you to switch to Desmos and type in your parent function and g of x, and just notice the relationships. And graphing calculator would work great too. All right, here I have a square root function. So my parent function is going to be something like f of x equals root x. Okay, so some critical points so that I can graph this well. I pick things I can take the square root of, so 0, 0. Actually, let me pick 1. Take the square root of 1, 4 would be 2, square root of 9 would be 3. And this time I have two things happening. My h value this time is, again, counterintuitive. My h is -2. And my k value is 4. So I need to subtract 2 from each of my h's, or each of my x's, and add 4 to each of my y's. So my original parent function here, 1, 1, 4, 2, is like this. And my new one, let's see, -2, -1, 2, 7, and then 4, 5, 6, and 7. So I'm going to graph these ordered pairs. And here is my transform function. So you can see that each point, so the origin is now at -2, -4, so it's shifted 2 to the left and 4 units up. This point, again, 2 to the left, 4 up. This one, 2 to the left, 4 up. In the next example, you're given a function and you're told to describe the transformations. As you do this, I would like you to use the order AHBK, all hail Burger King. So let's start just off on the side and see if we can identify what these values are. So just as a reminder, here is your general transformation. So do we have an A value? Is there anything in front of our parent function? Maybe you first need to think about, well, what is your parent function, which would just be f of x equals square root function. Okay, so is there anything in front of that A value? No, A is just 1 in this scenario, so we're not even going to need to talk about it, okay? Do I have an h value, anything added or subtracted to the x? Well, that would have to be under the square root sign if there were, so h is 0. So again, it's not anything I need to talk about. A b value, yes, x is being multiplied. It's equal to -3 here. I'll talk about that. And then k, I have 8 added on. So because it's -3, there's really two things I need to state here. First, I'm going to talk about the fact that it's negative, which means I have a horizontal reflection. So I'm going to say that it is reflected across the y-axis. And then the fact that it's 3, again, counterintuitive. This is where it's either stretched or shrunk. So this is a horizontal shrink or compression by a factor of, do the reciprocal, by a factor of 1/3. Which would mean you would actually multiply your x values by 1/3 if you were finding this by hand. And then my k value, off in the end, means it shifts up 8. Okay, now, just one other thing I want to mention. Doesn't matter really to me whether you flip-flop these two. I normally state my reflection first, but mathematically you could flip these first too. Okay, again, here's my most basic up at the top. Let's see what we've got. So do I have an A value? Yeah, this time I do. A is 2/5. Do a HBK. Do I have an H? Yes, this time something is added to x, so my H is opposite of what I see. It's -6. AHB. Do I have anything multiplying my x value? No, there's nothing right here in parentheses, so I'm not going to worry about that. It would just be 1, what it normally is. And then k, nothing added or subtracted to the end. So A being 2/5, this affects my y value. So this is a vertical. Now think, it's smaller than 1. This works how you think it should. It's a vertical shrink or compression by a factor of 2/5. And then I have an h value of -6, or you could look at the original and go it was added on, so it moves opposite. It's going to go to the left 6. So a horizontal, it's affecting your x, horizontal shift or translation, shift 6 units, and I gotta say direction as well, 6 units to the left. So you're always stating your magnitude, meaning your size and the direction. Okay, so 6 units to the left. Here's another one. Basic function would be a cubic one. So let's see what values we have. AHBK. Do I have an A value? Well, yeah, this time I do. I've got a negative sign. So I'm going to have a reflection. Do I have an H value inside? Yes. Opposite of what you see. So my H value is positive 7. B value, it's what's multiplying. The 1/4 there, and a K value, nothing is added or subtracted to the end. So since A is -1, this is a vertical reflection or a reflection that means it's across the x-axis. So reflect across x-axis. How would you do that? You'd multiply every y value by -1. And then I'm horizontally, I'm going to shift 7 units to the right, which means I'm going to add 7 on to every x value. And then I have a b value. This is counterintuitive. So it's smaller than 1, which makes your brain want to say, oh, it's shrinking, but it's happening to the x, so it's actually stretching. X is always the weird one. It's counterintuitive. Horizontal stretch by a factor of, do the reciprocal of 4, or 4/1. Okay, so now I have an absolute value function. So my parent function here would be y equals the absolute value of x. So let's check out what's happening here. All hail Burger King. Do I have an a value? Okay, so that's coefficient out front. Sure do, it's 5. Do I have an h value? This would be positive 3. It's the opposite of the sign you see. Do I have a b value? No, it's just going to have the same coefficient of 1 there, so I'm going to cross that off. Do I have a k value? Yep, got 2 subtracted off on the end. So first I have a vertical, is it stretch or shrink? This one works as you would expect. It's bigger than 1, so it's going to stretch it out vertically. Vertical stretch by a factor of 5. Then I have a horizontal shift. Which direction am I going? Right. And I'm going 3 units. Shift right 3. And then I'm going to shift it down or translate, shift down 2.